Another important concept related to quantitative research is the concept of measurement. Again, quantitative research typically has a bunch of measurements that allow us to categorize our subjects, such as a treatment type, but then also some aspect of performance that I'm measuring to see if a treatment or a exercise program has a specific effect on some aspect of performance. So measurement's an important concept in quantitative research. In human movement and recovery, the choice of measures is very important because there are tons of options. If you're attempting to measure some aspect of performance, if I'm interested in power, there's different ways to measure power. I can measure, again, jump height. I can measure force applied to a force platform. It's important that the researcher chooses the right type of measurement to help us make conclusions about the person's performance. So measurements that can be created include objective measurements, which are, again, things that we can physically measure with a device, whether it be a 40-yard dash time with a stopwatch or a laser timing system, range of motion, which we use a goniometer, or weight, which we can use a scale. Subject measures are often a little more difficult to measure, but use some type of a scale as well. But we can measure pain with a visual analog scale, ratings of perceived exertion by choosing a number from 1 to 10 or 1 to 20, depending upon the scale you use, or asking them the ease of their movement from 1 to 5. Measurements can then be compared to subjects within the study, but norms or a criterion or other populations. They also can be repeated for pre and post measures. Measures can include a wide range of different things, including assessments, where we are, using some type of a tool, whether it be a tape measure, a stopwatch, a testing device, a goniometer, or what have you, to measure some aspect of, in our case, typically physical performance or physical characteristics of some type. And then we compare them to other examples. So often we'll use norm referenced assessments. When we do like our overhead squat, we know what the norm is. We compare our findings to previous findings or to what is considered to be the normal reaction or normal motion, and so on. Often there are criterion referenced assessments where we can compare our findings to some relative level of performance. Example I gave before is, you can find online a list of average or mean 40-yard dash scores for football players of various levels. And we could compare the findings on our clients to those findings and so on. And obviously any type of assessment can be a physical measurement, a test, a performance measure, and so on. Another important tool that's frequently used in our field are surveys and questionnaires. And they can provide really useful information as well on a wide range of data. It's a frequently used data collection tool, and what we do is take the results of the survey, the responses, and turn them into numbers. So we can look at how many people said yes, or how many people said no, or how many people picked this over that, and so on. So these also are measures that can be very useful to us. So not always is it some measure of physical performance or physical characteristics. It can be responses on a survey. When it comes to surveys, often we're using questions. And there really are two general types of questions that we see on surveys or utilize as part of research in our field. One is a constructed response question, fancy term for an open-ended question. It's the other, when you have a choice of 5 things and there's an other box, or tell me what you feel about this. Those questions often kind of fall within the qualitative realm of research, but can provide some really useful information to studies that are quantitative in nature. For instance, if you were to give a person 3 different ways to stretch a particular muscle and find that, they all worked fairly well, or maybe some worked a little better than the others, but then you ask them the question of, hey, which ones would you be most likely to do, or which ones would you most likely add to your workout? And they, in their open-ended response, say, none of them, or they like the one but not the other. We can gain some really useful information from those open-ended type questions. Selected response questions are questions where you give them specific choices that they have to choose from. That includes questions where they have two choices, a yes and no, or true and false, or multiple choice questions where they have more than two choices and potentially can choose more than one response, and so on. Multiple choice questions are nice because what they do is they force people into these different categories and allows us to say, hey, X percentage of the population or of the sample chose this response, and X percentage chose that response. So it tells us, again, some information about the sample and hopefully about the population as a whole. Whenever we're taking any kind of measurement, these measurements are said to occur in certain types of scales. And we talked about variables at the beginning of this unit. I use some of these same terms. Nominal scales are where a person responds and they fall into categories. Either we place them into categories or their responses on these selected response questions puts them into categories. So if you were to ask them on a survey, what is your eye color? And you give them all the different choices, they would pick them. Eye color is an example of a nominal scale. It's categories. People are placed into categories, or the data is placed into categories. But there isn't a ranking. Again, green eyes, which I have, which are the best, they aren't actually the best, right? They don't fall at the top of the scale and blue at the bottom, or vice versa. There's categories, but without any ranking. Versus ordinal scales, as I mentioned, are categories of data, but there's a rank order. So if we were to ask the person, what's the highest level of education that you attended or education that you have, highest level degree, a PhD would be kind of the most education, and then master's after that, then bachelor's, then high school, and then no high school. So not only are they categories, but there is a rank order in terms of how much education they've had. Interval scales are measures that fall along a continuum. So we aren't putting people necessarily into categories here, but they fall along a continuum. So a Likert scale question would do that. It would kind of say, hey, where does the population as a whole fall? Do they fall closer to strongly disagree, strongly agree? What may it be? Ratio scales also fall along a continuum, but they include 0 as a starting point. So most physical measures, are going to be examples of ratio scale measurements. The quality of measures is something I want to spend a little bit of time on because this is really key. If measurements are taken in a haphazard way without care, then we can't have a lot of faith in those measures, right? So if you are testing people's 40-yard dash and you aren't always starting it at the right time or finishing it at the right time, then those measures really aren't of much value. It doesn't really allow us to say who was the fastest person, or is a person getting faster if we're measuring over time. So the quality of measures is going to be very important in studies that we read. Most again, research publications, peer-reviewed research, they're going to require that the person clearly describe how they measured some type of measurement, what devices they used, what tools and procedures they utilized to make sure that they were getting accurate measurements. But again, we also want to evaluate that ourselves when we read these studies. There are two main components of a quality measurement, and those are validity and reliability. I want to talk about each of these in a little more detail here and on a couple future slides because they're really key, right? Validity is does an instrument, when we talk about validity as a quality assessment of a tool, validity means is an instrument, is it measuring what it purports to measure? Can I trust this instrument to measure what it says it will measure? If I want to measure the length of a person's foot, I can use a ruler. A ruler is a very good tool for measuring length of a foot, right? Because a foot is flat, it's linear, a ruler is linear. It measures it very well. So it's a very valid instrument for measuring foot length. Now, if I want to measure circumference around a person's thigh, I could use a ruler for that too, right? I could roll the ruler around their leg until I come back to the middle. That would give me a measurement. I could also use a tape measure. Which of the two is going to be more valid for measuring circumference? I think a tape measure, because there's going to be a little bit of error. I'm going to slide that ruler around not perfectly and mess things up. Still gives me a measurement, but not as accurate, not as valid as a tape measure, which gives me pretty much, I can be pretty confident, a pretty true measurement of their thigh circumference. So validity is one aspect of quality when we talk about measurements or a measurement tool. Another aspect of quality is reliability. So not only does it measure what it purports to measure, but if I use that tool multiple times, does it measure consistently? So a ruler, again, if I was to measure a person's foot length, I'm really good at using a ruler, plus a ruler's really easy to use. So if I have the person put their foot down, I measure the length of their foot multiple times, I'm probably going to get very close to the same measure every time. Other measures are not as reliable, and it's harder to use them consistently. Even an example I gave at the beginning, a 40-yard dash, me starting the timer or a stopwatch and ending the timer or the stopwatch at the same time, I'm going to get a little bit of variability. Sometimes a little quicker on the start, sometimes a little slower, sometimes a little quicker on the finish, and so on. So that's going to have reliability, but not as good reliability as potentially like a laser timing system. That's going to give us much more accurate measures. So those are two important concepts, validity and reliability, that you need to consider as we move forward in this class. One other example I want to use is body composition, right? There's lots of tools to measure body composition. Some are really simple to use and don't need much information or much equipment. Others needed quite a bit. Well, the best way, the most valid way, studies have shown using cadavers to determine body fat percentage is underwater weighing. That's going to be the best way to measure body fat percentage in a population. It's kind of the gold standard. There are other ways. There's skin fold measures. There's BMI. BMI, I think we've probably all grown to hate it. BMI is a useful tool because it's really easy to do. You need a height and weight of a person and their age and gender, right? That's really easy to measure. And therefore, I can calculate BMI. BMI, though, it's not the most valid measure of body fat percentage, especially in physically active athletic populations. It tends to overestimate body fat percentage because it's built from populations. The formula was calculated based on populations that generally had higher percentages of body fat and lower amounts of muscle mass. So someone who has a lot of lean muscle mass tends to come on a BMI as fairly often obese or overweight. So BMI is not a very valid measure of body fat percentage in an athletic fit population. It is, however, incredibly reliable because if I put your height and weight every time in there, it's going to give me the same result every time. So a very reliable tool, but not real valid for the populations we work with. Skin folds, however, are going to be much more valid if the person is skilled at doing the skin folds. But again, is going to not be as reliable because every time you do the skin fold, you get a slightly different measurement and so on. Still a good tool, a little better on the validity than the BMI, but not as good on the reliability. Versus underwater weighing, when done correctly, is very valid, but also very reliable. So again, these are just examples of, again, what I mean by validity and what I mean by reliability. There are various components of validity and ways that tools are assessed for validity. And often you'll see, and we're going to see some in this class, examples of research where a new tool, such as Fusionetics or the overhead squat, is evaluated to see if it's valid. And typically, when a new tool comes around, it's measured for its validity by being compared to other tools that measure the same thing. There are different types of validity that are out there. The first is called content validity, and content validity examines a tool to see how well a measure matches what's being measured. But it's basically judged based upon experts in the field and so on. So it isn't necessarily mathematically or statistically tested against other tools to see if it's valid. It's a non-statistical determination or judgment of a new tool or assessment technique. Content validity is not the strongest type of validity when it comes to measuring how good a tool measures what we want it to measure. Construct validity is a much better way to test a device or a measurement to see if it is accurate in measuring what we want it to measure. In construct validity, typically a new tool, so if you invent a new way to assess body fat, and we would then compare it to an already validated measure. So typically, if you invent a new way to assess body fat percentage, we would compare it to the gold standard measure, which would be underwater weighing. And we can do that by taking measurements in the same people, using the same two devices, and looking and see how well they match up. And to do that, we use a statistical technique called a correlation coefficient, which gives us an R value. R values of 1 or greater, or 1, mean there's a perfect correlation. R values that are closer to 0 mean there's no correlation. We're going to spend a good bit of time talking about correlation coefficients and so on later in this course, so don't get too wrapped up in that now. But basically, construct validity is where a tool is compared to the gold standard tool for that measure. Concurrent validity measures how well a device matches up to other things that purport to measure the same thing. So while we maybe don't have a gold standard established yet, maybe we compare our new method of assessing body fat percentage to not underwater weighing, but to skin folds, to circumferences, and we see how well they all kind of work together and measure, again, the same thing. And we look at how close they are. Same thing, we get a correlation coefficient and will give us a strength of the relationship. Predictive validity means how well a measure is able to predict another measure. And again, so often you'll see how well one measurement maybe predicts something else. So this is when we think there's a relationship between two variables. An example of that might be how well, since we've been talking about the size of a foot, how well foot size predicts height of an individual. And we can actually see that people with bigger feet generally are taller, and therefore there's a fairly significant correlation between those two values, which means that there's a predictive validity between measuring foot length and height of an individual. So again, those are just different measures or different types of validity that you'll see mentioned out in the literature. Reliability is a little simpler to understand, but reliability is, again, how well a measurement or a tool produces the same results. So again, like if I was to look at a measurement of 40-yard dash, and I wanted to compare me using a stopwatch to using a electronic timing system, I would see that while I still may be pretty good at measuring these speeds, a timing system is going to be better. And typically the way that we measure reliability is through retest reliability. So we test people over and over using the same device and see if it produces the same result. If it doesn't, then that means that tool is not very reliable, or there's a level of error in measure based upon that tool. Skin folds is a great example of this. Even in very skilled individuals doing skin folds and estimating body fat percentage, they tend to get different measures each time they pinch and do the measurement. Now, their differences are much smaller than someone who's not skilled, but again, that retest reliability compares the pattern of scores on the same measure given over and over to the same sample, twice at least. Inter-rater reliability is another measure of reliability, but instead of testing the tool, it's comparing the raters. So when we look at, again, skin folds, if I'm new to doing skin folds, you'll see that I get wide range of different measures each time I do a skin fold pinch versus a skilled individual, meaning there's a lot of inter-rater unreliability potentially, and so on. But those are measures of reliability that also help us get at the tool, but also the ability of the individuals to utilize the tool. I've summarized or talked about a number of studies in this presentation. I also developed a lot of the content from the textbook Research Literacy, a primer for understanding and using research. So if you have more interest in the studies I've talked about, feel free to look them up. I'll also share them within the course.